Start my recording here. All yins out there and the rest of the world. Let's see here. Look at all these people. This is good. Who has my piece of paper for the week? Who has my piece of paper? We have it. Good. Just so you know, I'm not going to show the attendance / homework slide from last week because we didn't really have homework that you needed to actively participate in by the end of class, so I'm not holding you all to it. But I hope you all looked at the Meetup page and Meetup email that was sent to you that said, come up with a great idea of something that other people would want to download and learn the steps from that you create in Fusion for the final project. So hopefully you're doing that. Still brainstorming now. But we'll be discussing that in a little more detail later on today. So this is, you look like you're like itching to say something.
Yeah, there's two big trends. One is RepRap. Everybody know what RepRap is? Everybody know what RepRap is? Okay, awesome. So there's the printers. Okay. It's a group. Open source 3D printers, and there's quite a few new models. If somebody wants to work on their own model as final project, that would be awesome. There's also a similar project, humanoid robots, open source humanoid robots. It's also an ambitious project if somebody wants to take something like that.
Ambitious is right.
On which project will this?
Open source.
Here, will you throw this pen at somebody to Gordon sign this crap?
So there's something already there, like RepRap, it's huge. Open source humanoid is small, but there is also some links and files available.
Awesome. All right, so class today, we're going to be doing two things. 3D Cam, which is different than what we did last week, sort of, but not really. So you should all be comfortable with it, and discussing the final project. And it's still a work in progress, so we can have a good discussion about it. So the agenda, go to the webinar. So if you're cannot hear what's being discussed, well, we'll discuss it. It was just the final project, so we'll discuss that more. And also you're not here to sign the sheet, so you're in trouble. We're going to look at Cam with the pros, and by Cam with the pros, I mean people who have actually used the machine. What are they called here? Dream catchers or dream somethings? Dream consultants. That's what they are. Our dream consultants are going to teach us not only what James is pretending to know about as he goes through the class, but how you actually then use the machines to make this stuff happen. So some of the things that we were ignoring last week, like feeds and speeds and other great stuff, will be discussed in detail, and you won't have to listen to me the whole time. We'll go through a quick 3D Cam exercise just to get used to pressing some of the buttons, and then we'll discuss the final project. Why is everybody in here? Oh, okay. So this is the group. I don't think it means anything anymore, but we're going to say this is the group.
I made it to the room finally.
I'm happy that you're here, sort of. I'm bitter at this point, so yeah. This is going to be the exercise that we do, but we're not going to do it yet so that we can talk about actual use of the machines. Okay, I didn't know if you wanted to do it now or later, so this will be perfect. I think this would be a better time to go through it so that I can listen and learn.
Okay, let's see. More slides.
So we will start with the webinar.
These slides?
Yes, one slide.
Can I make this full view somehow?
Let's see. Full view is right
Top
click
right.
And never mind.
Hey, look at that. Still pretty good. Well, that's okay. Yeah, come up to the front and teach away.
Let me go around.
Go through the back door.
I squeezed through there.
So,
He's not designed to say that.
Yes, aboard with the move. He's authorized.
Some spacey music. All right, this will just be a quick overview of Fusion 360 in its relation to the Tormach, the CNC mill here at TechShop. Typically, Fusion does a very good job of producing G-code. Let's say Begley brothers, they could very much attest to that. Now, there are some hang-ups. We'll just be going over a very, very light overview of machining in general.
Did I click the record button? Let's make
I don't know.
sure I did. Yep, good to go. All right. Thanks.
Okay, light machining, Fusion 360 in its relation to the Tormach. Okay, a little bit about default parameters in Fusion 360's CAM package. By default, it specifies a 1 meter per second, 40 inches per minute feed rate. While this may be useful as a starting point for a vertical machining center, the Tormach is not a vertical machining center. It is a Tormach. These feeds and speeds will snap a majority of tools placed in the machine or crash your part. Running it at 40 inches per minute or a meter per second or meter per minute is just asking for problems. Going a little bit over the specifications of the Tormach, your typical, let's say your baseline Haas VF1 vertical machining center will have an 8 to 30 horsepower spindle. As you can see, Tormach has a 1.5 horsepower spindle. Now, typically, if you're running like what we give you in the class, 3/8 end mill, you cannot max out the Tormach horsepower-wise. You go larger than 1/2 inch, 3/4 inch, you can easily do that. Now, the maximum spindle speed of the Tormach is 5,000 RPM. You'll notice in Fusion, it defaults to 10,000 RPM as its default. Usually, that's about mid-range for most VMCs. Tormach maxes out about 5,000, so it's more equivalent to a Bridgeport style mill. Now, maximum peak torque for a Tormach is about 5 foot-pounds. Typically, you'll be actually only using inch-pounds of torque. You're taking a very small cut width off. You might be taking 2 to 3 thousandths per pass, per ship load. The peak torque of the Tormach is not at its maximum 5,000 RPM. You're operating typically in 2,100, 2,500 to 3,000 RPM where your peak torque range is. That's where you get the most useful torque out of the motor on the machine. Now, its maximum feed rate is 90 inches per minute. That is what you would have maximum for your jog speed, the movement between operations. Your maximum useful cutting speed on the machine is about 40 inches per minute. Typically, with the end mill we give out in class, you'll be running around 16 to 20 inches per minute. Now, if you want to build your final project here at TechShop using the Tormach or any one of the other machines, we do have a set of end mills to check out. You don't have to purchase them. They are high-speed steel. High-speed steel is a baseline tooling. It is essentially tool steel. It's not the hardest, it's not the best material, but it will get you through in aluminum and light steel. You shouldn't be machining titanium or anything like that. Now, there are some tungsten carbide end mills. That's what we hand out in class. Tungsten carbide is about 3 to 4 times stronger than high-speed steel. Downside, it's much more brittle, so you must be sure that your G-code is not going to have an abrupt start. You'll see in 2D there is the, what is it? It's the 2D, it's the one that has an unabrupt movements for facing. Can't remember the name of the operation exactly. Good compromise between tungsten carbide is M42, so if you actually do need to buy a tool if you want to do your project, M42 is a very good compromise. It's just a few, maybe 25% more expensive than high-speed steel, but it still has maybe double the stiffness, hardness of high-speed steel. It's not carbide level, but it's much cheaper.
So what's going to cut through like a 303 or 304?
Stainless steel. Any of the above actually could do it. Stainless, but it's the feed rate at which it does it and the time at which it'll wear out. So if you're doing 3D machining in a 30 series stainless steel, you'd probably want M42 or carbide to begin with. You could do it with high-speed steel, a decent American high-speed steel versus, let's say, a Chinese, Western European would be fine, well, Chinese, Korean, they're all good steels, but they'll wear out much quicker than M42 or carbide would be. So pretty much, let's say if you used RM mills up front, the high-speed steels on stainless steel, it'd pretty much be, I won't say it's an M mill per operation, but it'd be close. Depending on the quality, high-speed steel is just a hair tougher than stainless steel. High-quality high-speed steel will be equivalent, if not better, than M42, but even cheap M42 is still better than our bargain basement.
Can asphalt material harden during the milling operation?
Yes, stainless steel can work harden itself during milling operations, so you typically want to move as fast as you can. So the harder, the stiffer the tool, the better it is for the material itself. There are also some work hardening steels. Typically, you wouldn't be dealing with any of these if you're building a project, a gripper, shock mount, a electronic cigarette body, anything like that. You'll be dealing mainly with aluminum, maybe dowel rim plastic, acetal, nylon. Excuse me. Next slide. Okay, now, if let's say you're slotting a 1/4-inch hole, you're typically going to be running a tool that is smaller than that profile. There is a slot command in Fusion's CAM processor, but typically that will cause a bit of a conundrum if you're going exactly the size of your tool to your slot. You'll cut chips up, the chips will re-weld themselves to the sides of the slot. Typically, you want to have a smaller tool than the profile you're machining. Now, a little bit about tool length. I was actually talking to Begley's about this morning. You don't want to have, let's say they were using a 1-inch depth of cut tool to do a 1.5-inch deep pocket. Downside, you will not be able to clear the chips out of that hole. The length of cut, the length of cut needs to be pretty much equivalent to how deep you're cutting. If you've got a 1-inch deep part you need to cut, you probably need a 1/8-inch length of cut on your tool, unless you're dealing with a taper. So let's say you're working into a valley, then you'll always have chip clearance because of what you removed previously. Or if you have, let's say, a relief at the top of your part where you're making a 1-inch diameter hole and you have a 1.5-inch slot around the top of it. That will allow chip area clearance for the chips to extract. If you're trying to use a 1-inch length of cut tool in a 1.5-inch deep pocket, you're probably going to be rubbing the surface and destroying your surface quality. You're also most likely going to either weld your tool or pull it out of the housing. Minor diagram of an end mill. Some of you have probably all taken some of the machining classes or had some previous experience, but in Fusion, when you insert a new tool into your tool chart, you need to insert 4 measurements to overall tool length, length of cut or flute length, milling diameter, and also shank diameter. Shank diameter is not typically needed too much, but in Fusion you can do a little bit of calculations on how much horsepower and torque you're going to be using on the tool, so it will bring that in to measure the tool deflection in the calculations. Types of end mills. Typically what we have out front are square type end mills. You can see that on the leftmost picture. Those have sharp corners. Sharp corners break off in CNC applications, and they also tear out corners. If you're making a slot that goes all the way through the material, they're fine, but if you're making a small bottom corner, the sharper the corner, the more load you're going to put on it, the faster they wear out. But typically they're used in most 2D operations. Middle picture, you have a ball nose. Today we're going over 3D with James, so a ball nose tool will be most likely what you're going to be using for that operation. This allows you to cut around the entire bottom surface of the tool, along with the side surface. Ball noses chatter in most operations, so you don't want to run very large cut depths with them. The tool doesn't have much ability to self-center on it. You don't want to plunge like a drill bit with it, it'll just snap it. You have a radius tool, which is much like a square end, but you'll notice there's a small radius. A lot of the tools I keep in stock, I have 20 thousandths or 15 thousandths radiuses on the corner. What happens there is it gives you a much longer tool life. There's no corners to chip out on the tool. You can run them a little bit faster. Downside, if you're making a blind pocket. So let's say you have a pocket where you have a flat bottom, you're not piercing all the way through the material. You'll have a radius in the corner of the radius on your tool. So if you need to insert a pocket into a pocket, you'll have to take a finishing mill, so essentially just a square end mill again, and go to the bottom, clean out that radius. Another big one, Tormach, sometimes has a little bit of a problem with G21 and G20. G20 is inch imperial measurement system. If you're designing in Fusion and you specify metric and your post-process is to the inch standard, you're going to have some problems. Most likely it will determine F, which is feed rate. Let's say you set it to 9 inches or 9 millimeters per minute with your tool. And it's set to G20, which is inches. It will determine that that is 9 inches per minute, which if you're running, let's say, a very small tool, will snap it right off.
Can you stop? Does anybody know what G code is? Is there anybody who doesn't know what G code is?
Not very well.
It's essentially, it's an NC language. It was designed in the early 50s to run on punch tape. Now it's called CNC Computer Numeric Control versus NC Numeric Control.
I wouldn't worry about that.
Oh, it's a pop-up window.
Yeah, just click the little arrow to minimize it.
Yeah, let's get rid of that.
So how do you specify the G20 versus 21?
Typically, there's an MDI window on the Tormach. Typically, we'll load this code in for you from Fusion, but sometimes it does have a little bit of confusion about the, it'll give you some forward remarks and it will forget to put this in. Or if the person previous to you manually set the standard to metric or standard or metric, then it'll stay pretty much with what was previously set.
Is there a way to just easily reset that?
Yes, you just type in G, let's say you want to make sure you're going in metric, type in G21 right into the MDI window, hit enter, it'll manually insert that into your code. A good way to check is in the very top of the Mach 3 interface, it'll go over the G code that is running currently. Just check to see G20 or G21 is listed there. If it's not, manually insert it. And again, what I said previously I had on this slide, you typically need to have a tool if you're doing pocketing or slotting that is slightly smaller than the profile you're machining. Calculating feeds and speeds, this is the big one. Remember I was saying we had stock speeds of about 40 inches per minute and about 10,000 RPM. This is a feed rate calculation. So if you get out all your handy dandy calculators, I'm sure all of you keep your slide rule in your pocket. So this is feed rate, RPM, which we will calculate, times chip load, times number of teeth on your cutting tool. Typically you'll run 2 to 6 teeth. What we have are 2 and 4 tooth tools. Psych, we're just going to use FS Wizard. FS Wizard, very nice program. Free version, not as nice as their pay version. There's also G Wizard, very nice as well, but much more difficult to get a license for. Just hold it up for a second. Didn't like that. Feeds and speeds wizard. This software package, there's also feed and speed wizards that are on the Tormach. Allows you to specify, you'll notice in the top window right there, the type of material, in this case a low carbon steel. I'm just going to give you the measurements, the numbers you would use with the tool that we would give you out in the class. In this case, we are going to machine, I'll say, give me a material.
So pardon me, you're saying this is an online tool?
Yes.
6061?
6061. Now, again, HSS, you'll notice HSS Cobalt, that's M42. Carbide, then you have diamond. You don't need to worry about those. We'll go with carbide. Now, the type we're giving you has a tin crin coating. That stands for titanium chloronitride. Then you have tin titanium nitride. That's a yellow color. If you ever get a drill bit with that, a little bit of trivia, the only reason they put that titanium nitride coating on there is not for wear life. It's the easiest coating to put on. It's also the one that sounds and looks the coolest. The other ones look dark and gray, blue colored. It's the one that gives it no shebang. Now, units, inches, metric, pretty simple. The tool diameter we give out in the class is a 3/8.375 with 2 flutes. Length of cut is 1 1/4 inches. We do have 4 flute tools, but what we give out in the class is a 2 flute, so I'll just...
So is it because of its aluminum?
Typically in aluminum you can run 4 flute, but you have to adjust your feed rates. What happens with 4 flute tools, you have to feed them faster, and aluminum will re-weld to the tool if you don't feed it fast enough with enough coolant. So typically in aluminum operations, you want to run a 30 to 45 helix degree 2 flute end mill, or a 3 flute end mill in the 40 to 45 degree range. What we run is a 30 degree end mill. Now you'll see length of flute right there. Corner radius, I can define that, but what we give out is a square. You can also define a ball nose or bull nose in there if you need. Shank diameter, I'll just make sure that's 375 just so the numbers line up. Now depth of cut, width of cut. Typically in machining terms for our machines, you want to go 50% of your diameter and 50% of your diameter for depth of cut and width of cut. So depth of cut in this case will be 0.1875, so 3/16, half of. Now width of cut, typically I will go half the diameter or less on that one. Now if you're doing a slot pocket, select that tool, it'll go the full diameter and change the math a little bit. Now you'll notice even FS Wizard defaults to about 10,000 RPM. That's a typical machining number you would have. I'm going to default it just to 3,000 because that's about where the torque curve for the Tormach is. Now surface feet per minute is a chart used for determining feed rates. It's really dependent on your material. I have a chart in the next slide. You'll go over some rough numbers. Let me just calculate that real fast. Thinking. Okay, now what it wants for that carbide end mill is about 34 inches per minute at 100% feed rate. Now you'll also notice we also calculated some other numbers down here. It's using about 8.3 inch-pounds of torque. That's well within the 5 foot-pounds the Tormach can do maximum. It's also using 0.4 horsepower. But the big thing is here is a tool deflection. The tool is actually going to deflect some at this feed rate. So I'm going to decrease my feed rate some. I'm going to take it down to about 50%, at 50% of both of these. This will probably drop me about 16, 17 inches per minute. Now that tool deflection is much better. The torque is about the same still, horsepower dropped. The machine, really, you're not going to ever use more than a horsepower on the Tormach. But about 17 inches per minute at 3,000 RPM is about right for the tools we'll give you. If you're getting your own, you'll have to calculate your own speeds and feeds with it. Now, that being said, the faster you go, the more material you'll remove, but the faster you go, the more likelihood you'll have bad surface finishes with the Tormach. The machine has a very large, I guess you could call it a perfect storm kind of area, where tool length, bearing play, gives are the bearing surfaces of the machine, will cause vibration. Dinner's coming back to haunt me. Will cause a lot of vibration in your tool, a lot of screeching, a lot of chatter on your part. You typically have to play around your feeds and speeds with that one to remove that chatter, that screeching. But I really like FS Wizard. They do have an app for your phone, but it's only limited to 3 types of materials.
I would like also to add, when you calculate the feed and speed, please pay attention to 3 things. HP, horsepower, it should never exceed 1.5 because it's maximum for Tormach, 1.5.
Also the torque and another one, tool deflection. If you have more than 1,000th of tool deflection, pretty much assume you're going to have a horrible surface finish and your tool's going to break.
So in this case, drop down this well disadvantage.
And another thing, if you wonder what other people are running, they do have a chart of all the last calculations for the speeds and the feeds and the different cut rates. So you can actually see a lot of what other people were running previously, feed rates wise, for a very similar tool description. And probably a lot of those are me.
So weren't you concerned that some minimum feed rate would actually cause rewelding of the chips?
Typically, the faster you go, you can re-weld chips with the faster feed rates. Though typically the Tormach, it really happens because of excess spindle speed. The machine doesn't have the ability to get to the feed rates that would cause problems there. You'd be up in like the 45, 50 inches per minute kind of feed rates to get rewelding chips. Spindle speeds, on the other hand, if you're going too fast or too low of an RPM, or sorry, too high of an RPM with too low of a feed rate, you're going to cause the same problem, just in the opposite direction. It's kind of like a bell curve, like up this way and down that way. So, FS Wizard once more. Let's see. Okay, these are some typical surface feet per minute. They do have metric versions of this chart. Typically, if you actually do want to run those code, run about a 200, 300 to 1,000 surface feet per minute in aluminum. If you actually want to do the math. We also have bronze, steel, machinable iron. You can find these charts in the machine shop on the wall if you really want to do the math by hand. Same with chip loads, different size tools, different size chip loads. That same chart we did a minute ago, but with slightly different numbers. Now, again, I was saying screeching chatter. Typically, that comes from excessive tool deflection, i.e. you're using a high-speed steel tool and running numbers for carbide, or you have an overly long tool. Let's say you're running one with a 2-inch length of cut, and you're cutting 3/8 deep. Also, it comes from a little bit of machine vibration. The Tormach is not the most rigid machine ever. Now, how to fix it? Typically, start with decreasing your feed rate, followed by using a shorter or stiffer tool, i.e. use a shorter carbide or use a carbide versus a high-speed steel. Now, the screech you'll get on occasion, typically you can adjust that by your RPM or your spindle RPM. Too high of an RPM will just screech regardless if you have perfect feeds and speeds on the XY. Now, G-code for Fusion 360 is pretty much spot on for everything other than two things. On occasion, it will parse a G91 and a G28 in the same line. This is telling it to do a part remove to do a tool change, to pull it out of the material. Downside, if you put those both in the same line, when you put the Z0 command or Z anything command in, it'll lock the Tormach. To get out of that, hit cycle start and it'll kick to the next line and then you can keep on going. Typically, just manually put them onto different lines. You see it in your code. When it brings up the code post-process window, just hit spacebar and enter, put them on different lines. And also M998, that is for an automatic tool changing position. The Tormach does have the capability to do automatic tool changes. To onside, we don't have the automatic tool changer. So if you do run into the M998 causing a problem, make sure you reference the machine before use. If you don't reference it, it will not have an idea where this position is and again will hang. Now to get out of that, you have to hit cycle stop, rerun the code from that point. And that was my last slide. So there's the two big ones for Fusion with CAM, but there's really nothing wrong with Fusion 360's CAM processor other than those two small problems. And the bottom one is just caused by the Tormach being its own happy self. The upper one, I don't really know why that one does that one on occasion. Sometimes it's intermittent. I think it's the code, the web kind of window that pops up the code that does it. I think it's bringing up the wrong post processor. Also, don't bring up the wrong processor. That's just asking for trouble.
The wrong post processor.
Yes. Wrong post processor. Yes.
You can search for G91 and make sure that.
Yeah, just find it, add a space. If they're on two different lines, the code works perfectly just as it's designed for. If they're on the same line, it'll cause a hiccup and cause a block. And most of the time, it actually does put them on two different lines. But let's say pasting the same set of code the other day, first set of code, same processor, was fine. Second set of code, had them on the same.
But before you close, could you discuss generating G-code for the shop file?
I do not know if Fusion has that post-processor capability. Actually, I can figure out in a split second if you want me to.
Okay, here's what I found, and I'd just like you to comment if you had experience with it, was Alex and I used the generic G-code, and then found that it didn't have the ShopBot header in it.
Yes, ShopBot uses very specialized versions of G-code. Typically, the only way you can get that header if you need it is to copy it out of an already existing set of ShopBot code.
That's what we used to.
Yeah, that instead of using F commands for feed rate, it uses a M3, which typically in normal Fanuc generic G code would be spindle start clockwise. So if you are using the ShopBot, I can check in a minute to see if Fusion has the ability to post-process there has it for ShopBot yet. But typically, if you do want to use it on the ShopBot, you'll have to copy that out of a pre-existing program. There are some on the desktop on the ShopBot computers, so just copy the first 3 lines till there's a remark or pause for 2 seconds. So that'll be the first about 10 lines.
Could you comment on 2 things
Yes.
from last week? So I made about 47 different tool changes throughout the little process, and rumor has it that that's not super efficient.
Yes. Now, tool holders for our machine and most other machines, a tool holder for a Tormach is about $30. A tool finder for any other CNC vertical machining center is about $150 to $200. The least amount of tool changes you can do, the better. If you have to have 3 different drill bits for drilling a hole in a 1/4 plate, it might be just easier to throw the end mill that you're going to be using for your final chamfer mill in there and just use that to bore a pocket out versus drill it out. The minimum amount of tool changes you can get is probably the best for the Tormach. It is a semi-automatic tool change. You have to open the motor case, put in the tool, re-zero the height. There's not an automatic tool height setter. There's not tool height compensation, or tool diameter compensation on the machine automatically. So you have to enter in every tool height manually on the machine, or use a paper trick with cigarette paper or Post-it note to gauge tool height off the top of your stock. That is a time-consuming process. If you have 47 tools, if you're doing it manually, you're going to add another at least 30 minutes to your machining time before you even start. If you are in a shop and you're running Fusion and you have 47 tool changes for the part we were running last time, that's obscene unless you're making 80 of these things at the same time. Now, typically, with the part like we were running last time, we probably could have done it 2 ways. We machined holding position or machinable vice jaws. Machinable vice jaws, you can get them or make them. You can do the same thing as machining a clamp. They go right in the vise. You can get them on eBay for like $10 to $15, or you can machine them out of bar stock just as well. Usually bar stock's cheaper if you don't value your time as much as machining, just buying it. But they're very nice. If you need to machine an odd size part like that, you would just do an outer profile tool path into the actual jaws themselves to allow you to grip the component. Or you can use pin locks for holding it down through the drill holes from the first operation. But typically decrease the amount of tool changes if possible, just for time concerns. Second,
The pin locks and how to actually do it.
so if I remember correctly from the cam we were doing last time on the spring attachment, we had 3 holes they were drilling originally, or yes, the 3 holes. Typically, we would have a square piece of stock for that component. We would drill those holes first. From there, we could use what is known as a fixturing plate. We would use just a square plate, it goes underneath the material. We put bolts down through those holes, allows us to machine away all the remaining stock on the outside of the part without having to add tabs. Removing tabs is another 2 post-process operations, bandsawing them off and then polishing away the remains of the tab. Now, if we machined it with clamps, we would not have this, but typically machining it with clamps is another operation or 2 operations before even machining the part. So typically just a slab of aluminum or steel with bolts in it is the faster operation. Now also we can use that same block to fixture for our side machining or slotting using 2 of the other holes and just orienting it 90 degrees in the other direction using the same block. Or depending on how we have set it up, we can have the same tool that does our outer profile to our slot just by having 2 of the same part on the same fixture block in the machine. So we can save a tool change there. I can probably throw up a diagram of what I'm explaining if you can't get it in a little bit.
If you're changing the orientation of the stock,
You would have
how
to-
do you change the tab, the tool path?
Typically, what you'd have to do is actually design like right now, you have the cam up for right there. If you wanted to machine that, you'd bore out the one hole, do the flip.
Yep.
Now, the cam for the next orientation, you have a copy of that part in your file you'd have to design in your jig plate in there into the file with the part. Essentially, you'd have another copy of that body at 90 degrees
at an
on,
orientation.
yes, at the correct orientation. So you'd machine a block there. That way you would only have to have one tool change for 2 parts essentially. So if, let's say you did 20 pieces of square stock with all the holes originally, you can then put them onto the jig plate and do the outer machining. Once that one side's done, you put it on the side of your jig plate or your other fixture. That next end mill, as it's doing that profile, will come in with the second set of G code, do the slot through the center of that plate. So finally, the only thing you have to do is the last set of G code, which is invert the part and do the final profiling on the outside edge for the second side and the chamfer on the back of the back pocket.
You want to use taper pins to locate things, or
Typically,
screws, or
just screw shoulder bolts.
aren't there kind of some? Isn't there?
No, if you get a shoulder bolt, it will have the diameter, which, unless you're specifying like 4.1 inches or something, or 0.42 millimeters, you will have a shoulder bolt the size of whatever pivot bolt you're going to be running. Like in the part there, we had 10 millimeter holes. You can get 10 millimeter shoulder bolts. You might actually even have a problem getting the shoulder bolt into the hole. There'll be interference fit. You might have to lightly sand the shoulder bolt to make it fit. Or you can machine a pin into the plate and then just use a work holding clamp to hold the part down.
Thanks.
Anything else?
I would like to see, you said you could get a picture of that bolted.
Yeah, I can throw together a quick model real fast.
I'd like to just see what that would look like. Also, if you could check and see if, as of today, or when I checked, I couldn't find anything at the shop. So,
Okay, if I've looked in the last couple of days, so I doubt they've upgraded the amount of post processors in the last 20 minutes or so, or hour a day. But I'm sure James will let us know when they do.
Of course, yes, absolutely.
Any last questions? No, I'll let James get back to his.
Well, that was wonderful.
God, it's a college credit. With the
Right?
information right there.
Can you put his little
Yeah.
PowerPoint file somewhere we can get it?
Absolutely. That just scared me, to be fair. I was like, oh, it's a lot easier to just watch the little thing go through in the software and say, looks good to me. I'm a little intimidated at this point.
It's very much scary to see a machine crash happen, so it's
Oh, yeah?
worth
The due diligence.
Yeah, I'm sure.
One of my grandfathers, like he would machine things in wax.
Oh.
He had a machinist wax, and he would run things and he would test them. And they didn't dull the tools, and if there was going to be a crash, it would not damage anything. And we would run it in wax, and we get a good one, then you can go and run it in the actual material.
Machinable wax is awesome if you check on the fits and speeds, but if you, for example, run an in matrix instead of inches, it will run inside of the wax and no matter what. So machinable wax is awesome, but it doesn't protect you from everything.
Cool.
You would still crash your space probe onto Mars, even with the wax. So,
That's pretty cool. Look at all these tricks that you guys have. This is neat.
And there's even stuff on the web that you can make your own.
Oh, yeah?
Elastic bags and everything.
Wow.
Yeah, you need to shred it first and use your oil fryer to fry it.
Oh, come on.
Let me tell you what I'm not going to do.
do.
I'm sure that the first time I machine something here, I'm going to be completely confident that it's going to work on the first try and then watch it fail and be upset.
With your green consultant to walk you through it.
That's right.
I think.
All right. So
How many
who's,
of the dream consultants, by the way, are versed enough to,
Help you with the machine?
yeah?
What? Yeah.
I'm more interested in the shop bot, by the way, than the,
Zero.
then we're up to zero, okay?
But the shop, there are quite a few more, like Grandma, he runs the shop on constantly.
please grab all.
How many?
The ShopBot, there are solutions where you can just take it from the Fusion file and put it into vCarve or something like that, right?
You could
You
export.
don't, you don't have to
and
use the
accept
CAM
interface.
as the interface with it. You can use one of the other ones, but that's.
Oh, so I can take my model and put it into vCarve and let vCarve do the G code?
You can still
You
do
could
that.
do that, but
You'd like
it's
to get
a
it in.
post-processing step.
Need to
It'd be-
extract the projection of the face. It's 2D information basically.
So if, let's say you have a half depth pocket, you'd have to remember every pocket depth that you have, and then redo all of your CAM operations and depth operations in vCarve. Well, vCarve is very nice for post-processing from strictly 2D operations where we're dealing in 3D. If you did do 3D and for some reason it does not work in Fusion, you could use Cut3D. But Cut3D's 3D modeling operations are amazingly primitive compared to Fusion. So typically it'd just be better to stay in Fusion.
Yeah, I think what I've modeled is fairly simple, but I certainly don't want to be cutting through the scrap board or not called scrap board.
Yeah, that's fine, yeah.
Those kind of, I know, the $80, yeah.
Does TechShop have Medellas?
And now,
Medellas.
Dallas?
Yeah, they're a small little CNC machine. No.
Sacrifice board, that's the word.
Awesome. So any other questions before we go and click around in the software? No? All right. So let's go ahead and open up Fusion.
How do we do that?
How do you do that?
Yeah. Anybody else excited about this class being over? Yeah. Oh, so while we're on that topic, this class isn't over. So I know. So my long-term plan now, by long-term I mean further than this class, would be one more week. Now, not next week and not the week after that, but somewhere down the line, I want to have one more class where we all come together as friends and show off our final projects that we worked so diligently on. So this will give you time to figure out your idea, come up with what you want to do, form teams as necessary for some of them perhaps, and then actually do an outstanding job of modeling and documenting your steps. And then when we all come together, we can have pizza and bears and go from there and show off all of the cool work that we did.
So when are we going to get our fancy certificate?
Well, at that class, that would be when you would be getting your fancy certificates. So it doesn't count against you in your scoring if you don't show up, but you need to do your final project to get it anyways. So
tonight's homework won't be due until that class?
Tonight's homework will be finish your final project. So yes, it will be due at that class. And so at that time, food, drink, show and tell, and go from there. That's the plan. Now, when is it? I don't know. James is going on a road tour for a few weeks after this class. So we'll have to figure that one out.
I have a question.
Yeah.
Will you be doing this again in the future sometime? This type of thing?
He looks like he's in pain.
So that's up in the air at the moment.
No pressure, just curious.
I would like to, very much so, if Autodesk allows me to do so. Is another thing, but we might have others that have learned so much that they want to continue the learning.
I would request that the next one be Inventor.
Inventor. If we find somebody who knows Inventor well enough to do all of this stuff in the Pittsburgh area, I would request that they do that as well.
You'll be happy to be a student.
I would love to be a student for that. All right, so let's move on. If we all open our data panel, we can scroll down to a project that we should all have access to called CAM samples under the samples. So if you scroll all the way down, you'll see CAM samples. And one of the files, you're going to see 3D strategies. don't cheat, don't be a jerk and open 3D Strategies -complete, because you're not going to learn it. Well, you might learn something from that. Open the one that just says 3D Strategies. You can just right click and open it. And you can see this beautiful looking file, model, whatever it is.
Looks like a mold.
It's moldy. We could make it green in the rendering environment. It does look like half a mold. All right, from there, go into the CAM environment. I'm just leaving mine in this little view here. Let's see if we have any questions. We should have been listening to questions. My bad, people. Yeah, that's about accurate. Scare the hell out of me too. There's a light wizard app in Google. Okay. Free. There we go. All right. So let's minimize this thing again. So we all have our stuff open here, right? No computer?
God's stolen.
Oh, well, that's no good. Would you like mine?
It's simplified my life at this point.
That's good, I guess. All right. So just like last time, let's close our data panel. We're going to start with a new setup. And we're going to pick this little bottom corner. Last time we were clicking this little arrow around, whatever. This is what it's going to look like. It's pretty easy. Pretty easy indeed. And I should have a little box open somewhere on my screen, but apparently that's not the case.
Question. The Z should always point out of the work, right? You're going to machine from that space into.
The Z should point out of the work.
That's the way you want it, right?
It is. The Z is outside of the work.
Whether it's
Correct.
up, down, or sideways.
Right. Now the question is, where is my little pop-up thing? My setup box. Here, setup box. Well, that's unfortunate.
Can you right click on setup one and edit?
That's what I just did, and I did no luck.
So we should do this every once in a while, where the pop-up just disappears.
Well,
It's interesting to know.
Is that because you have a dual monitor and it's on the other one?
it shouldn't be, I don't think, but let's see what happens if I... Well, let's not do that, apparently. Oh. Hi.
About Davey Rock's, I don't have access to this file, I don't know.
It's, okay, go back in Fusion. Now, let me scroll that way.
Uh-oh, now I broke the projector.
There's no file on the drive, it's under
There's a
samples.
source button.
It's under here, that'll be CAM samples. That will be in the drive.
Yeah, there's something different.
This,
I went to samples in my folder and
there, it's not in your folder. It's under the name, data plane code. Samples file.
I know, see? Look at what happens.
Did you find your file?
It did pop up now.
That's something to do with the fact that you weren't going.
Yeah, well,
On that.
oh, it's in the actual Fusion. I'm like,
Maybe just your HDMI cable and plug it back in.
okay. Yeah. Yank this thing out. Stuff it back in. Hey! Well,
Hey, the stop window came back.
the stock window's back and it's not on my screen, so that's That's not helpful. My screen,
Duplicate.
my screen's black, so it's not playing nicely.
You know, your screen.
So maybe the frequency, monitor frequency's out of range.
What's that mean?
You may have a higher resolution display on your laptop than the projector's capable of reading.
Optimal resolution notification, okay. So what do I do about that?
1024 by 1920 by
1280 by 1024? Okay. Plug back in.
There you go.
You have it here? Nope, he doesn't have it. Display two to the drop down.
Oh, this isn't helping, is it?
Select
Select what?
one, you highlighted one.
And I looked at that.
Doing no such.
Maybe you need to go back to 2 and select it for that same resolution. 1280. Yeah.
That one?
No, well, you want to make it the same as two, you want to make 2 the same as 1.
Yeah. Isn't 2 the same as 1?
Yeah, because 2 is your desktop, right?
I don't know.
Well, I guess they changed the file.
Son of a bitch. This sucks.
No, but we were all.
I called the cavalry.
Thanks, I appreciate it. Make this happen.
Problems on this side.
You just can't see it on here?
I can't see it on there.
Pay no attention to the Alex sign.
It takes it out of the resolution.
And then he unplugs it and plugs it back in.
It says you have 3 displays plugged in?
I don't know what the heck's going on.
The laptop display is probably a higher frequency resolution. So why did the well, because he was on different displays. Here, it wants to repeat what's supposed to the display to be the same.
Am I that good?
Okay.
So while Alex is fiddling, what distinguishes a 2D or 2.5D from a 3D model?
I thought you did the reading last week.
Thought maybe you would want to refresh our memory.
I think the pro should be answering it.
In other words, you're passing that one on.
I am passing that one. I always say it's fillets and things of that sort. So things that are manipulating in all 3 axes, X, Y, and Z, versus just working in the X, Y plane. So in our other one, we were kind of going up and down in the Z plane, but this one can do like curves as well.
Okay, but the last one, to me, was kind of 3D, but we just took it out of the vise and put it back in a different way to do the 3. That's the half D?
Yeah, that's the 2.5, yeah.
Okay.
So that's what the shot lot is. It's
So, yeah, but then a 3D, you still have to take it out of the vise and in the vise?
Yes, if you
To
need
change
to do.
axes? For like undercuts and things?
Yes, undercuts, anything like that, you have to reorient the part unless you have a 5 or 6 axis CNC mill, which
Okay.
can then rotate its head at an angle or rotate the part at an angle. Usually it's the part to allow you to get to that undercut. If you're doing a 3D machining, you'll be moving an X, Y, Z axis simultaneously, but if you still have an undercut or another edge or another surface that the mill cannot get to with that, you do have to reorient the part. Now, 2.5D is typically is you're moving an X or Y, and then a Z change, X, Y, Z change.
Yeah.
Or sometimes it's Z change and then Y change. Like you could do an X, Y wrap with a 2.5D, where you could do with the fourth axis. Fusion doesn't have fourth axis code yet, so if you actually do need to do fourth axis work, the only software package in the shop that can do it is InventorCam or actually VCAR.
Okay, so I have not taken the SBU on the Tormach. So is that something where the milling tool rotates around?
No, the milling tool in this case is fixed and moving an X and Y on the bed with Z changes on the spindle.
Okay.
If you do need to use fourth axis, let's say you're CT milling a gear, you can add a fourth axis to the machine, but to do that code, you would have to either use Inventor at the moment,
Okay,
or you would have to use VCAR.
just because of the tools that we have here.
Not so much of the tools, just because a limit to the post process. When the fourth and fifth axis get in Fusion, you can do that all easily in Fusion. Right, at the moment, the only packages you can do it in TechShop are either InventorCam or VCAR.
Just bring a chair and turn your face to the screen and work with that.
This is funny.
It should make it the
On
same.
the eighth class, it's like, well,
Oh, no, we've
We're
had some
giving up.
kind of technology problem every time.
seriously, but to this point,
Alright, this is final project.
yeah.
This is like Christopher Columbus seeing seagulls, you know. Time to turn around and go back.
No, we never.
Do you know that reference from the 70s by any chance?
Queen Isabella's favorite.
Did they plug it in down there, right?
I assume.
Oh, yeah,
It
working for a
was
while.
working.
What did you touch?
I don't know what I did.
That's what happens when you.
Mm-hmm. I think you get.
Never delete the Windows folder.
Should we use the new hardware? Oh, no, that's just for go-to. Never mind.
To extend, that's worse.
Oh, that's something.
Yeah.
Yeah, but
I still know it's
you'll
not
still have to
mirroring.
look up there.
I don't really care. Yeah, that's a little closer.
Yeah, I still know why it's not mirroring.
If you are gonna use the extend, make sure the people on the go-to meeting see the right one.
Yeah.
Because they'll only see one of the screens. Or part of one.
This one's kind of cool. But we can't see if it's one.
So I'm just gonna answer a question. My 12 linkage model, did you get to talk with the guys? Did the guys ever get back to you on that?
I sent it again today and said, hey, guys, and explained,
Basic
it
explode.
looks good, expand or change parameter, explode. Come on. So we'll see what they come back with.
I'm curious, I really want to put that out to the world. I'm curious if it's even possible to close that link.
Yeah. Well, that's really what the question is, right?
It may not be.
Yeah. I can just use it looking at the
I don't
screen.
think you can.
That's
Okay.
okay.
No.
I wouldn't mind.
Well, Sandy says it can't be done, so, yeah.
He's a physicist, he knows.
There's the
I
answer.
don't know, it's just a guess, sort of based on watching it and knowing it's.
Reboot.
Still extending it.
Still extending.
You guys see the fourth dimensional base?
Excuse me?
There's a fourth, like it's not
I
really a
just saw
fourth
part of it.
dimensional base, but it's shaped in a way to where you pour the liquid in through the bottom and then it goes through a funnel and then goes into the actual
base
Well,
itself.
think about the climb bar.
Climb ball.
Yeah. That's pretty cool.
No, but I designed something that could possibly be fabricated in real life, but may not be completable.
No, I think it's gonna be
Maybe
it
a
on that.
rigid object, may not be, it's a series of 12 linkages that may create a kinematic lock if you complete the 12th link.
Okay.
If you have 11 linkages and don't create the kinematic loop, it works. But the question is.
Well, I wonder if that's the problem.
What?
It's stuck recording.
I think this might be part of it. Yeah, sorry.
That's okay. Yeah, don't worry about it.
You just get one of those triangles.
It makes things exciting this way.
Yeah, so did it just stop working all of a sudden?
So I couldn't find this setup box, which is now extremely large. It was not on my screen, and now it is on my screen, which is helpful. So, yeah,
Your part's
that's
not
good.
there anymore.
It'll show up, that'll be fine.
Do you want to put a chair over there so you can?
Nah, I'm good. We're gonna blow through this. All you guys are experts at this point, so it's not a problem. Thank you, sir.
Yeah, sorry.
All right, so if we remember from last time, we clicked that little bottom corner,
Broke it.
and now Phil broke it, which isn't surprising. And we're going to go ahead and change our stock. And instead of a fixed size box, we're going to use our relative size box, which is the size of a relative. And we're going to say the side offset is 0. We're going to leave the top offset at 1 and click OK. As you can see, the part's gone. But I think if we flip the screen, oh, are you freaking kidding me?
Zoom out, maybe. I think that it thinks that it's a bigger screen than you do.
Zoom to fit.
Okay, so those operations, what you just said them quickly, those operations were to set the origin?
Yep, set the origin in that bottom left corner
Okay,
so that the z-axis is pointing at you.
okay, got it.
And then when you're in stock, use a relative size box. There it is. Look how happy it is. So I'll go through the steps for you right now. So we're going to move this guy down here. Boop.
Stop.
Stock, we're going to change our mode to relative size. And we're just going to drop this side to 0. And we're going to be so happy. And click OK. So that was easy. I
So
mean,
what's the top offset? Which one of those is the top? Now that
well,
you got Z pointing up.
if we edit this and go back here, let's put a 10 in here. And you can see it grow. So
That did around all sides.
the top is the Z
Okay.
pointing out. And we could just keep typing numbers in there as we so desire to find the rest. So I guess we'll consider this the top, which is where our machine, when we start adding actual actions in here, you're going to see the tool facing that way. All right, so let's get started again. So after that very, very long first step, let's go ahead and we're going to actually start out with some of the operations that we did last time. So under 2D, we're going to choose face. And we're going to choose a tool that we're pretty familiar with. So if we click select, we're going to scroll down to the bottom, and instead of using this one, let's go just to the tutorial folder this time. And we're going to choose this very top 50mm face tool. Edit, and you can look at all of the various dimensions of what we have there. If my eyes were any good, I could tell you if they all match up still. So that's what they should look like. And let's keep in mind that our friends that are using Macs are not going to have all of the same exact workflows, but relatively similar.
Tool number 1, what, I missed, what tool did you pick?
50mm, the very first option, the very first one.
Under what?
Under tutorial.
Very well.
We'll click OK. Bless you.
How many loops did it have? Sorry.
Whatever the default. Oh, you don't have a default, do you?
They
I think
should have
it's-
The facing tool should have clues at all, should
Whatever, 2? What was it last time, 2? I don't remember. Select. And now we can go through the various options here that we have, like our geometry, our this, our that, and the other thing. And when we click on geometry, it's going to show us where it's going to be doing that first operation, which makes sense. And we're pretty happy with that. So if we click and drag our box, it shows up big again, and we click OK, and it shows us that first pass that it's going to be doing. So last week we went through and simulated it every time. I don't think we really need to go watch the simulation each time this week. Does anybody need to watch the simulation? Okay. Maybe just once. Maybe a couple times, but. All right, next.
So how did you get to that with this? Did you show the path?
I clicked OK and select. So next I'm going to go ahead and again use something we did last week, which is the 2D contour. And we're going to select our tool, and from that same tutorials folder, way at the bottom, we're going to choose the second one here. Well, that's convenient. 16 millimeter flat. And yes, I know we already discussed that you're not supposed to change tools all the time like we're doing here. But in Autodesk land, that stuff doesn't matter because your time is not valuable to us. So you can spend it changing tools all you want. That's not entirely true. I think your time's very valuable. But for the learning process, we're going through all of these clicks so that it ingrains into your mind how to do it. So that when you're using just one tool, you go through it without having to go to the forums or emailing James. All right. So those are some great looking values to me. Are they great looking? Sure, why not? Yeah, look good to me. Click OK. I like that. That's so much fun. Click OK. Click select. And again, we can choose our geometry, our heights, so on and so forth. So for our geometry, we can go ahead and click this back wall, and it shows up in blue. And we can verify our heights. So that looks good to me, the stock top and the selected geometry. And let's go ahead and click OK. And so now you can see that next operation since it's highlighted, and around it shall go. Pretty easy so far, right? Everybody remember this from last week that was here?
Where is the parking held?
That's a heck of a question.
It's got a super magnet on it.
It has a super magnet on the bottom. That's accurate. I don't worry about these details.
Because the toolpath is under
The toolpath is going to cut all the way around it. I don't know.
From the backside.
Yeah. I like that. That was a good question.
One hand and then
when it's coming by, slip your hand in the middle. If you just grip it right here, even though that's not machined out yet, it'll be good to go.
try really hard not to move it though.
Come on now. Some of us are going to have major neck cramps by the end of today, and here you are asking me questions. So let's go ahead. That's a great question. Let me bring that up with our people that do this shit.
Which needed the mirror.
We covered this one already. It was a suggestion, yet nobody. Jeez. But nobody has mentioned it to our problem. Well, you guys are such problem solvers. But I still have to use the mouse. Here, let me sit over here. Maybe this will work. Here we go. All right. So now let's use something that we didn't use last week. How about that? So under 3D, boop, you see we have all sorts of other fun options. 2D, boop, 3D, boop. And we're going to use adaptive clearing. Now this thing's kind of a jerk. So the other two that we were using, it was like, ooh, done, my path is fast. Boom, my path is fast. When we click on this guy, you're going to see that it takes a little bit of time for it to figure out what's actually happening here. So let's go ahead and somebody should have numbered these pages. Whoever put this together today did a shoddy job. Let's select our tool, scroll down to the tutorials folder, and we're going to choose a ball mill. Didn't we get told that we're going to be using the ball mill today? I think we did.
What?
I was just saying you were right.
Which one?
We're going to use the 6mm ball, number 21 to be exact. And we could choose to edit and look at all of our values. Yeehaw. Everybody see those? And click OK. And select. Now, we should be modifying our feeds and speeds from very intimidating tables or hand calculations that we would be doing, but we're not going to do that in this class. We have a very special machine that's allowed to move at these rates, apparently. If we click on the geometry, we're going to uncheck the stop contours. And we're going to choose to start from our previous operation and then go to our heights. If I try and scroll this out of the way a little bit, that's pretty easy. Top to back, that's always good. And this time we're actually going to fiddle with the passes. So again, in Fusion Land, we're going to change these numbers to what we want them to be. And that looks all fine and dandy to me. And click OK. And when you do this, you're going to see a little calculation show up over here as it's calculating all of the work that it's going to be doing. So you see we're leaving a little bit of stock. So now you can see boop, 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 calculating, calculating. Here's our tool over to that side. And that's what it's going to be doing from this first calculation, or this first move of the adaptive 3D we're using. So let me go ahead and right click on setup and choose simulate. And, oh boy. I'm going to make my stock show up and make it transparent. And if I can move this over a little bit, we'll make it go fast. We can, oh boy, that's too fast. Oh, that's okay. We can see all of the work that it's doing here. And you can still kind of see the material cut away. That's pretty fun. So we won't watch it every time, but I just want to show you that it's a little bit different than what we were doing last time when it was just removing a little bit of material and drilling straight down. This one is, I would say, significantly more complicated than what we were doing last week. Now, looking at something like this, how long would something like this take in the real world? Is this, oh, that's not so bad, or is it, well, you're going to break your tool, you're going to wear it down, you're going to like take forever to do this?
So 6mm ball mill, and you're running at about 20 meters a minute at about, I think, 20,000 RPM. Use 20,000 millimeters per minute. Those are not anywhere near real life figures unless you're running some of the new Mazoc tri-axis machines.
Mm-hmm.
Typically on a Tormach, for the size of this component, you'd be probably running about an hour, hour and a quarter for that machining operation.
For that operation alone, and then the rest of them, for us to clean this up, would take a bunch more time.
Significant time, yes.
Okay,
Longer
awesome.
tools like that, especially ball mills, need to be run at about a third of what a square-ended mill would be.
Oh, okay. So this is good to know. It scares me again to even think about going and making something, but all right. All right, so let's go ahead and again, go to 3D. And let's do some adaptive clearing again. And this time we're going to choose another tool from the tutorials library. And this time we're going to choose the 5mm bull nose. And click OK. For the Mac users, you need to type in all these numbers each time, correct? Or some of the numbers each time, right? So it's good that I show them?
Yes.
Yeah.
Okay.
It's a good bit different.
Yeah, it's got a
Kind of
fairly...
cheat and pick number 14, like, right, because that's the tools. that you
Yeah,
can
yeah,
look
number
for.
14 should be good. Click OK and select. And again, we're going to be able to go through our stuff here. From previous operations. Heights, we're going to leave alone. And passes, we're going to set up yet again. And modifying our stop delete. And again, it's going to go back through that area that we were hacking away at last time and remove a little bit more of that material. Notice how long it's taking this time versus those initial operations that we were setting up that are very fast. It just smacks the material away.
What we're using, a 2-inch surface mill or something.
Yeah, last time we used the... All right.
I just thought, you know, my computer is at 19%.
Of the first one or the second one?
No, the one you did. So you completed yours.
This one. Gotcha. So yours is at 19% right now?
Or 23.
Oh, so you're getting there.
It's a
TechShop computer? Time for a new computer then. All right, so another operation. Drop down, and this time we're going to use horizontal. So if you take a look at the text in the little image, that's going to be what our part looks like. So it detects flat areas. So if I move away from here and I rotate this around a little bit, you're going to be able to detect our flat areas in our part. So something like this would be flat in here, these surfaces. So we're going to be going through and trying to detect these flat areas with this operation. So we're going to leave our tool the same this time. That's easy enough, right? Geometry. There we go. And in geometry, we should be able to click on these various faces to get everything to show up the way we want. Well, maybe we don't have to do that right now. No, we're not going to do that.
Or you have to detect it, you have to specify.
What's that? So it's going to detect it for this one. For the next operation we do, we're going to have to specify what's going on.
So under geometry, we don't have to click anything?
No.
Not even selection, just none?
So under heights, we're going to go from model top, delete -1, and our offset, and our bottom, we can leave at 0. We make that 0, you see where it's at. We make it -1, going in just a smidge. And passes, we could go through and change it again. Blah, blah, blah.
I only press OK, it seems to work.
What's that? We're going to turn on our axle offset path. 0.4 and 3.
On in the Meetup site?
I did not, but I can put it up there for the next time, or for you to go grab.
Yeah, that'd be great, because you're going over them quickly and I'm not getting all the settings right, but
Sure.
I can go with the PDF.
Okay, that works. Click OK. And there it was, nice enough to detect those for us. So it's a lot smarter than I am. It can go ahead and just pick those very quickly for us. I guess it's really not that difficult to figure out what surfaces are flat.
But the challenge would be it has to have a lot of material machined away to get to them.
Yeah. Well, so those first 2 operations, yeah, lots of material. So again, probably multiple hours to get to this point. All right. Let's go ahead again and use adaptive clearing, or I'm sorry, contour, 3D contour. Select, and we're going to use the 6mm ball again.
Just a quick thing on that last point before you get to going.
Go ahead.
If you did one quick operation in there where you just set it, but didn't state kind of why. You stated that you were going to go slightly below the surface, to a negative surface. If you fail to do that negative value in that surface, it will also machine the surface.
The top, yeah.
Because it's selected as a flat surface.
Right.
That's,
So
yeah.
you have to.
It helps to understand
remove that
why you're
from
doing
the
the
set.
-1.
Thanks for pointing that out. That's wonderful, because we already did make that flat, and I assume it looks nice now. So I guess that goes back to our garbage in, garbage out, which I tend to put a lot of garbage in. So if we wouldn't put that -1 in there, we would be screwing up the work we already did. Awesome. So let's select our tool.
So now we're doing contour. How do we get to this thing? Contour.
Just under 3D and choose contour.
Contour.
Finishing steep walls for semi-finished and finished machining. Steep walls. Oh, uh-oh. We have a few little glitches in this program where stuff just kind of disappears and goes behind ribbons that it's not supposed to go behind.
I don't know. I probably want to ask one of the developers about that.
So anyways, let's go ahead and put an additional offset in there. And if we check slope, we're going to have a nice slope angle in there. Gabe, why are we having a slope angle in there?
Typically it's for clearing of the tool. Also, it helps with chip clearance.
Chip clearance.
Pringles.
Just buzzwords.
And passes.
Yet this side of the chuck doesn't mill very well.
No? Is 30 reasonable? 30 degrees? I mean, is there a limit? Clearly there's a limit, but what is said limit?
Degrees, typically there is, that's typically when you're doing it. There's right angle there. Typically, you'd want to watch out for head crash, so it depends on the profile you're machining. If you have something with a very sharp angle, you're going to have less degrees than something that's much flatter open, but you don't need slope if you have a flat, more open part. So typically, probably be about 45 degrees if you have a front max or slope.
Okay. Awesome. Oh my gosh. So next we're going to do, I pass it up, parallel. Finishing strategy. Shallow areas. Select our tool. We're going to be using the same ball mill. And so this and the next three are pretty much all for finishing in detail work. So this one, the parallel, and then using pencil are all for like the finer details and milling away smaller amounts of material. So again, I think you'll see in the next few steps, we probably are changing the tool too often because we're using like 3 different sizes each step, even though it's doing the same thing over and over again. So go to our geometry, and this time we actually do have to do a little bit of work. Silhouette, we're going to have our additional offset. Nope, nope. So if we choose tool inside boundary, so let me leave this up here for us to look at. So tool inside boundary, the entire tool stays inside the boundary. So what boundary is that? Well, if we go in here and we would click these different areas that we're looking to machine out. It would now stay within that blue path, or any other path that we would be creating. So this is kind of a pain in the ass. So selecting the path that your tool is going to stay inside and finish. So you can see this thing that I selected is not supposed to be selected. It's all supposed to be on that plane-ish. Oh, don't click escape. Apparently it will get rid of all of your stuff.
Just going to make a request. You're going through all of these. One that I'd like to see you do is to constrain the machining within a projected area. So when you're doing contour planing, you can project an area onto a plane and then constrain the machining to just within that selection.
One more time, I'm sorry. When you're doing?
Remember that contour thing I gave you, that ridiculous thing that took 28 hours to machine?
Yeah.
The way Alex cleaned it up was by taking those C-shaped regions that were with the contours map and projecting those up onto a plane, and then constraining the machining area to just within those projections. So I think it would be useful for other people if you cover that.
Okay.
And it's an option when you select constrain area, which is what you're covering. Constrain area. Inside boundary. See? So if you project a plane up onto, if you project the geometry up onto a plane, then you can select that boundary. And it can save you a huge amount of machining time, like from 28 hours down to like 6.
Yeah. So then you select the projection that you just made, and that's where it's going to stay machining inside of, versus the whole part.
Right.
Ugh. Though it doesn't exactly make it easy to select them when you don't have them projected onto a surface. You would talk to somebody that works with the code on that, right?
Yes.
And again, we're going to use -1 and click OK. And see what we would be milling away
I would hope multiple passes.
in multiple passes. I was tired of flicking on the passes screen. And so the last operation or operations that we would be using is pencil. Creating toolpaths along interior corners, fillets, small radii. So small detail work. Sound about accurate? That's what we would use a little pencil small tip for, is small detail work. So how many of you think you'll ever actually go machine apart now?
I was going to do that before, but yeah, now.
How many of you said, this looks like too much work? That's kind of what I thought was, man, this looks really difficult. I think I'll need a lot of hand holding before I can be successful at it.
Plus you need to part now.
And you do need to do that, which is, I'm told, very safe, but I'm not certain. So in our tutorials, let's go ahead and scroll down and use 3mm ball. I guess I scrolled too far.
Ooh, what's a lollipop?
So question for you guys in the back. Right now we're about to use 3 pencil operations. We're going to use 3mm followed by 2mm followed by 1mm. Is that reasonable because it's changing the tool those 3 different times, or does it make more sense to just use the 1 and have it go to town?
Breaking down those operations, so 3 and a 2 and a 1. Typically, the smallest tool is the one that's most required for the operation to get the radius. But depending on the operation, let's say we have a bottom radius of 4mm, we can easily get away with 2. So you want to calculate the largest tool you can fit into the profile you're machining. But typically, 3 tool changes for something like that would be a bit much. 2 would probably be more effective. Or using 1 tool change with the smallest tool and then using a much larger clearance tool for the main pocket.
And often we have control of your 3D model, so you may want just to change the 3D model, not to have such small tools to change the design.
Assuming that the design can get away with such changes.
Yes.
Yeah, typically.
Okay.
1mm ball mill is like.
It's a 16th inch.
That's
ball
small.
mill, essentially. They're compatible for the most part.
All right, so let's go ahead and just do it with 2. We'll go with the 3. Select. Go to our geometry. Go to our heights, which we don't have to change again. Passes, which we can change again.
What is a bitangency angle?
Don't look at me. I've never heard that terminology used for anything.
That's where you go to Google or the CAM forums and say, so I have this bitangency angle. Could you tell me what that is?
It's probably bit agency.
Bit agency. Bit
We're
agency.
talking about bits, right?
Sure. At least for our class, it can be bit agency. How about that?
An angle in degrees that is used to detect passes along a wall. Of course, it's not.
So let's zoom in here and we can see what this operation is doing. So like we looked at, all sorts of little detail work, which is lovely because then our part's going to be nearly finished.
See, but that's very useful because it's doing it not as fast, but it's actually contours. So it's cleaning up all that noise that was gotten from the sort of milling operations that happened as basically raster. This was using that vector of continuous contour. Much nicer.
So there. And that's what it really comes down to, right?
Yeah, that's all that matters.
So one more time, let's go ahead and choose pencil if I can find it again. And this time we're going to use the 1 millimeter and select. And I don't know if we have to change anything other than passes. I'm skipping a step, so we really won't have to do anything other than passes. And we're going to make this much smaller. So all sorts of detail going on here. And again, it's going to go through, and I suspect it's going to have a very similar path to what it had last time, and it does, which is not real surprising. And so, in my extremely novice opinion, I would say that's not significantly different than last week's example, other than additional operations and significantly more complex geometry that we're working on. So instead of just taking material off the outside and drilling some holes in, clearly much more complex shapes and going to take much longer to do. So let's go ahead.
But you could do this whole thing from one z-axis. I mean, we didn't have to take the part out of the vise and put it back in. Everything you've done has been from the initial setup.
Right, everything that we've done is from one setup, but let's keep in mind that where is it actually being held at? Are we holding it here? Well, we have it going around the whole outside on the back surface. So in my mind, it would probably be held back here somewhere near the end, where you would go through and do all of these operations, and then you could maybe machine it away.
Loading it off the end of a larger piece of stock at this point.
Yeah.
42 hours right now.
So that's what I was just going to say is, now look how long it's just taking to run this simulation of showing you where things are going. Just imagine how long it's taking to actually mill this part.
Plus switching the tool.
Yeah, plus switching the tool.
So what
Now,
are
is
the
this
red
realistic?
sections on the progress bar? There's red sections. Is that like congested traffic?
Congested traffic.
The yellow lines, you think?
No, the red
You just went red and now it's in green again.
shaft collides with stock. Bad. Don't do that, is what I hear.
So what is the tool change?
Loves that it crashes.
It crashed on yours?
Yeah, let them send you a report. Has anybody gotten a report back after they've said, send me a report when you know something?
Does it say, send me a report and I will get back to you? I don't think it says that. I think it says, send me a report so that I know that the software is crashing for some reason and we can improve that.
Yeah, but isn't there a checkbox that says, let me know when you know something?
I don't know. My software doesn't crash, so I don't get those sorts of reports. Not entirely true. All right, so those are our camming operations that are very easy and it's not intimidating at all. So for any of you guys probably don't even need to take the class offered through TechShop because you're pros and you can go use the machine now. Alternately, any questions that you have, I would point towards the back of the room and ask them. But before you do ask those questions, let's go into my little deck here and talk about our final project. Now, I don't want to call this a competition, but I feel like everything should have a little bit of competition in it, right? Who doesn't want to think that their project is the best? Everybody does. So the amount of work that you're going through might be rewarded. It probably won't be, but it might be. So the final project, all sorts of open loose ends here that you can tie up in any way you see fit. It could be an individual project. It could be a team project. Now, I don't mean everybody in the class is going to work on the same thing, though if it was a monster project that we came up with, that would be pretty cool. We see some of the suggestions that we've already had in class, or from the class. I think we got about 6 or 7 different suggestions. One, it's a part that's already created, so I kind of ruled that out and said, at least make something new. 2 was, no, I'm not going to create out of the computer, I'm not going to create the actual hand, but I'm going to download the hand and modify it so that it works in a different way, creating new parts, and then would also be able to be laser cut. So I think that's a kind of interesting project, and it might be something that somebody else might want to download and manipulate from there, especially because 3D prosthetics are such a hot thing, it seems, at this time. And another suggestion was, why doesn't everybody build part of the Mousetrap game? So if you look at Mousetrap, I guarantee it's the craziest game you'll ever see. Is that how it goes? I don't remember. Well, I think it would be interesting for a few people to maybe get together and do that, where they created the Mousetrap game, only so long as it actually works. Because I have never seen the in-the-box version of the game work myself, where you roll that stupid ball down and all of that stuff happens and your mouse gets trapped. I've never seen it successful. So if you could actually...
Yeah, you had to.
Okay, well...
You had to buy the quality game.
Well, the version of the game that I had never worked. So if you could actually get it to work, I'd be very impressed. And, you know, I bet one person could model all of that game. 3D printed parts. So anyway.
Does that fail the useful criteria?
I would say that fails the useful criteria. Dan, do you think that fails the useful criteria? See, I feel like it kind of does. I don't want to say it isn't useful, nor do I want to say nobody would be interested in saying, oh, let me download that.
We would like to have such project that people would like to repeat. People would like to take this project and maybe modify it or 3D print it, or nail it. So there will be some future to this project. To build a community of fusion users, 3D printers and so forth.
Right. So that's what I was trying to express with my think Thingiverse, but useful, or think Instructables for this. So I can go on Thingiverse right now and download any hundreds and thousands of parts. But what good are most of them? Well, it's a Yoda head.
Files and we cannot modify. This is largest minus of Thingiverse. These files will save them in GraphCAD, for example. People can take them and put their addition to this file.
And they can keep growing the files and databases available of useful files that aren't STLs that are pretty much garbage after turning them into such files. So another thing that I would like, so let's say that you go with Mousetrap. Is that it, Mousetrap? Yes, Mousetrap.
Spherical ice.
What's that?
Spherical ice balls.
Spherical ice balls? I don't know what you're talking about. Okay. So anyways, let's say that, as an example, you choose to go with Mousetrap. I also would love to see some instructions on how are your parts made. Not, here, James, I made, what is it, a bathtub. Well, that's not very difficult to make. But what are the steps that go along with it? So what if somebody wanted to learn off of your Mousetrap game? They could also follow along with the steps that you took. Something I might suggest for you that could help you with this process is a program that can be added into Fusion 360 called Screencast. Screencast is a super valuable tutorial type thing where you click Screencast, and if you don't have to ask me how to get it or install it, just Google Screencast for Fusion, and the Google machine will tell you how to do all of these steps. You basically install it, it's super fast, you log in with the same information that you do with Fusion, you click record, and it's going to record your screen as you go through the process. But not only that, it's also going to record audio if you so desire, so you could talk during it, but it will also record all of your clicks. So it will say, I left-clicked on extrude, I right-clicked repeat fillet. It will tell you all of your commands, so you could easily document what you did, or if your program's crashing, you can repeat them and show them to us easily what the problem is. Not that that ever happens, but if it ever happened, that would be useful. So I would highly recommend / encourage / demand that you do a screencast whenever possible.
It's on the forms, Autodesk forms.
There we go.
Say that again?
It's on the Autodesk forms. How did you screencast with Fusion?
Okay.
As a download link?
What about if you're just really trying to get a good sculpt of this thing? You just go through so many iterations of trying to model it. Is the screencast helpful then, or do you have 5 just epic fails?
I would have various answers to that. People actually request for us, by us I mean people who still make videos, not me anymore, to record what we're doing like you're actually making it. Where, oh, I hit this problem, how do I go back and fix it? Or at what point do I Control Z and remove it? So maybe it would be good to have something like after you fail a couple times, you're like, I'm getting pretty close, record that session and show some of the operations that you're going through. So I do think there is some value to that.
So I'm still having trouble with the concept of something useful. Okay, I mean,
my original plan of something useful, or our original plan of something useful, as an example, would be a bolt that is fully parametric.
Okay.
So hex head, 3 inches long, threading applied to it. Okay, now I'm changing the parameter to 2.5 inches, and I want it to be octagonal or something like that.
So you're saying useful from the point of instructing in Fusion.
I think useful as in somebody would want to download that file to help with their project or change in the future.
For example, right now Fusion has access to McMaster. You can press a button, you get to the McMaster, you can choose any item in the catalog, download it, and it appears in the Fusion. But it appears in the Fusion as just, solid object. There is no parameters. And McMaster, for example, doesn't have all the inventory of the bolts, the nuts, whatever parts is there, U-shaped parts. If you could take that and just make it parametric, if everybody would submit one part, that would be already 30 different types of parts, not just one part, but types of parts. And next generation of engineers could use the work, could use it for their assemblies and so forth. So if you do it right, it will grow exponentially.
Just one question. There's conventions in especially inch parts, maybe not in metric, but in inch parts. So if I made a 1 inch diameter bolt and whatever thread that is, 6 threads per inch, I don't know what's standard, 1 inch 6, I think is.
And there's different fine course, okay, so it's a question.
And then when you scale it down to 1/4, I have a strong suspicion it would scale down to.
Who said scale down? Parametric.
No, I'm saying, but parametric. So if I change the diameter parameter from 1 inch to 1/4 inch, it would probably scale down to like 1/4.
You don't scale stuff. Parametric is exactly that. This is parameter to the function. It will behave exactly in a way how you describe this function. This is a model. It's not just, scale everything by 2. You set up the different values for different,
You have table lookups and parametric configuration.
I don't think so. There's scripts, but it's
all automatic. You put in the parameters of that part and that's the way it is.
I'll ask you offline. I think there's a gap in the logic in that one, but I'll ask you offline. Okay.
Okay, so your interpretation of useful certainly can vary. I'm not going to say, no, your project's the worst idea I've ever heard. That's pretty mean, so I probably wouldn't say that. But if you can justify why it's useful, why somebody would want to download it and modify it to make it their own, I think that is probably a sufficient term of useful. But keep in mind, Instructables did that. Upload the finished, I would suggest rendered version to the Fusion 360 gallery to show off all of the great work that you're doing. Because why wouldn't you want to show off these great finished final projects?
So with a hashtag,
We could use a hashtag. Would you like to use a hashtag?
I don't know, that's a question for you. You open it.
Sure, why the heck not?
TechShop PGH.
TechShop PGH, okay, let's add that in here. With hashtag
I have no idea how to use that.
TechShop PGH. How about that? You can use that as a tag, and then we can search with hashtag PGH, and they'll all show up in one nice little window for us. So it will be easier for us to find all of them.
PGH fusion classes?
Excuse me?
PGH fusion class?
Two.
What message do we want to carry with first?
Well, what do we care? TechShop PGH? No, I mean really for sorting, that's pretty much all that we'll be able to do.
Yeah.
The gallery's still pretty limited. And then, right now, I'm saying the project is due and going to be presented. So after you make it and you come to class, you're going to present it to us as to what you did, maybe talk about some of the steps, and we can all enjoy each other's work that we put into our final project. I don't know if that's the actual date. Stay tuned with respect to the Meetup page. We need to verify availability at TechShop as well as with when I'm actually going to be in Pittsburgh again. I think that's, oh yeah, completion is necessary or you fail. You don't want to fail after all this good work you put in, so.
We can't use our extra credit from the
The extra credit does not, it almost covers, but it does not cover this final project. So try and do as great of a job as humanly possible on this. So one last thing I'll say before we open it up to more questions is if you want to be added to part of a team, like if you can't come up with anything, let me know. And if you can come up with something that would be a cool team project, let me know. Because I can try and group people into various teams as necessary so that you can all work on the project. It will be up to you to set up the A360 project, which we learned how to do, and invite the various team members to it to make sure you all have access. So feel free to email me if you just can't come up with an original idea of your own, and I can loop you in with other people who will be very angry because who wants the guy that can't come up with an idea on their own? But that's okay, you know, feel no pressure.
Along with the last person chosen for the team.
Right. So who has questions, comments, concerns?
So we can bounce everything through the Meetup page? I
Sure.
think that's where we're doing.
Sure, bounce stuff through there.
So are you going?
Am I,
2 weeks?
what's that?
Would we have any access to you in the next 2 weeks?
Oh, no, yeah, for sure. Email,
Okay, but not physical.
Meetup, not physical. I'll be in New York, Boston, San Francisco, and Boston. Oh, yeah. Yeah, it's going to be awesome.
Truly
Make
bouncing.
up for liberals.
Yeah. So it shall be lovely. Meetups all over. Woo.
Usual?
Fusion. Fusion with 3D hubs. Does anybody know 3D hubs? It's like, so say you have a 3D printer sitting at home and you're like, well, what am I going to do with this other than make trinkets? I'll make trinkets for other people. So you put yourself on 3D hubs and you add yourself to their network, and somebody close to you can submit a job that you then print for them and you get paid for it and send it off to them, or they meet somewhere and pick it up. So it's kind of cool. There's something like 17,000 3D printers on their network in North America right now. Yeah.
Wow.
Are they the ones with the big center at Cincinnati, right next to the airport? That UPS does all the shipping out of?
I have no
They
idea.
have like 60 3D printers and they.
No, it's diversified. You could be one of the users.
Yeah, you could be one of the people.
Oh.
So
Gosh, that'd be awful.
that.
And then like releasing other people's meshes, like.
Yeah. That's what I always wonder about is how does that happen? I feel like somebody's like just downloading a Thingiverse thing and saying, print this for me, but I don't know. I don't know how it works.
I've had to fix a few meshes when I hate it.
Yeah, it's pretty awful.
It's really bad. I use Sculptress and it created, like the brush that I used created this knot of just infinite triangles.
Nodes and yeah,
so
elements.
I had to go in, in the program I was using at the time, I had to go in and like slice it up and take it out.
Yeah.
There was an object I saw on the internet of a 3D printed, it's supposed to be the world's largest 3D printed object. And
Largest?
Yeah, the world's largest. And what they did was they designed this form, and they had every member of a conference print a piece of it,